I got this Philips CD Soundmachine and it's not giving any sound. The display lights up, so that's okay. So I selected radio for now as a source, FM frequencies. 92.6, that's a known frequency. Let's crank up the volume. Nothing. So there's no sound. That's a problem. Let's open it up and see what's going on inside. In order to open it up, I'll have to drill out these plastic covers. There are markings where screws are hidden behind the plastic. And indeed, you can see here, it is just a plastic plug covering the hole where the screw is in. So let's do the others. I'll start by unscrewing those 3 screws and see if that's enough to open the case. Let's see if we can spot a problem right away. Connections are okay. No loose wires, as far as I can see at the moment. This is the main board, the controller for the CD player, some sound processing ICs. This looks like an op amp. We got the main board free for closer inspection. Let's see if we can spot any problems. So this is the fuse. I can check that later on. The voltage regulator, I guess. This is the microcontroller for the Soundmachine. This could be some kind of storage, like an SD card. This is the output section of the amplifier. This connection is for the right speaker, this for the left speaker. This is the amplifier IC. One of the main features of an output amplifier is its cooling plates. It helps you to find the output amplifier. If you see cooling plates, you're probably close. This is the point where the power supply is connected to the display board. The display board is over here. But we already concluded there is no problem in the display board. I don't see a clear problem at the moment. So the first thing to check is the power supply. 9.7 volts, that's the main power. 3.3 volts, that's the power for the microcontroller. Not all parts require the same voltage, so we may see different voltages. I don't have the electronic circuit in detail, so I don't know the exact voltages. But all in all, it seems the power supply is okay. My next plan of action is to select a source, in this case the tuner, and see if I can find where there is still some audio available on the circuit board and where it has disappeared, in order to try to find where the fault is. Let's see if we can select the tuner as a source, search mode, and it finds a frequency. So I'll guess the tuner circuit is functioning properly, as it finds frequencies where radio stations are at. 100.7 is a known station here in the Netherlands. So let's see if we can trace the signal from the tuner. In a previous project, I built this AudioFinder to trace audio signals on such a circuit board. You can check out the video on my YouTube channel. I'll leave a link to the video in the description below. And with these 2 probes, I can see if I can trace the signal. So this is the path of the signal I'm going to check first. the signal, the left channel from the tuner is going to pin 16 on this audio processor. So let's see if we can find something there. Pin 16.
5 kilometer, 10 minuten.
Wow! Wow! We have radio, guys! So the tuner is operating perfectly. The signal gets to the audio processor. Let's see if the signal comes out of the processor. So that should be at pin 23, 24. 1, 2, 3, 4, 5, 6. The fifth or the sixth pin from this audio processor. So let's see what we got. 1, 2, 3, 4, 5. Very nice, very nice. And 6. No problems there. So the audio processor is okay. And it goes from there to this operational amplifier. Let's see what we got in the operational amplifier. This is the operational amplifier, the op amp. So the signal is coming in at pin number 3. Let's check that out. Well, that's okay. Not a very clear signal, but there's a signal, definitely. And the output of the channel is pin number 7.
20 juli 89 was het
Ja.
eindelijk zover.
There's a signal.
Een van de beste wielrenners van Nederland
Definitely.
ooit, de
Let's check at the audio amplifier if the signal can be traced at the input of the audio amplifier. This is the audio power amplifier. It's upside down, of course. It's on the other side. So I'll have to look at the pins the other way around. First check what pin number 12 is. That's where the power is going to. This is the main power supply for the IC, and that's pin number 12. So this is pin number 12. The input signal is at point 6 and 7. Pin 7. We got music. Pin 6. Also music, so that's okay. The signal is going into the power amplifier. The output signal is pin 11 and pin 2. So let's check those pins. Nothing. Nothing. So there's signal going into the power amplifier IC, but there is no amplified signal coming out. So the issue of this machine is clearly in this IC somewhere. Okay, I got the data sheet for the amplifier, and it says here in the data sheet there is a power on-off switch at pin number 1. So the IC has an on-off switch. Let's see if it is turned on. It should be also around 9 volts. 0 volts. So the power amplifier IC is turned off by its power on-off switch. Why is that happening? In the circuit diagram I can see the on-off switch of the power amplifier is controlled by this little switching circuit. So what we could do is bypass this circuit and see if the power amplifier will turn on. In order to do that, I just short the power supply voltage from pin number 12 to pin number 1. As this is only an on-off switch, it will not draw very much current. So I think that will be safe to do. Let's see what happens if I connect pin 12 with pin 1. All right. We got radio. Basically, this little circuit consists of 3 transistors turning the switch of the power amplifier on or off. Let's locate those 3 and check if they are okay. Let's get my magnifying glass. These are the 3 transistors controlling the on-off switch of this pin number 1. Maybe there's something wrong with these transistors. I can check if there's a short in these transistors. For example, if I connect the base to the collector, there should not be a short. If I have a short circuit, you'll hear a beep. Also, the collector and emitter should not be a short. So this transistor is okay. Is okay. This one is acting strange. There's a short in the base and the collector, and there's also a short between the emitter and the collector. That's not okay. So this transistor could be the problem. In the circuit diagram, it's this transistor right here, and it acts as a switch to provide a supply voltage to the on-off switch of the power amplifier. So let's turn the switch on by bypassing this transistor and shorting the collector to the emitter. Let's try that. Now I'm going to short the collector and the emitter of this transistor. And we have sound. So this transistor is not doing what it's supposed to do. So is the transistor faulty or is the capacitor faulty? I cannot test this while these components are in the circuit. So I think I'll have to get my soldering iron out and take this transistor out and swap it for a new one. And I can take out the capacitor 115 and check it while it's out of the circuit. So it's something like this. All right. So that's the new transistor. Looks kind of funny. Let's check it on this component tester. This capacitor is broken, that's for sure. The component tester thinks it's a resistor, which is clearly not. Could this be the issue all along? Let's get another capacitor. I'll need this one. Let's put it in. So let's put the power on and see what we got. Yeah. So, it turns out it was a faulty capacitor and transistor. It looks like the repair is done, so let's put it all back together again. there you have it. The sound machine is fully operational again.
Daar zal technologie deels de oplossing voor zijn. Maar of voor dit specifieke...
If you like this video, please hit the like button and subscribe to the channel. I'll see you guys in the next video.